Hello, everyone. Thank you for joining us today. Welcome to the first talk of 2023 and the first talk in our Celebrating Systems Engineering Digitalization series. We're really excited to have this talk embracing the initial vision of SERC Talks with our esteemed panelists and sharing their viewpoints in open discussion. We hope you find this discussion beneficial and encourage your active participation. So as I mentioned before, please feel free to let us know where you're joining us from via the chat and talk amongst the rest of the audience. But any questions or comments you'd like posed to our panelists, please utilize the Q&A module. If you are joining us by phone only, feel free to send any comments or questions to serctalks@stevens.edu for incorporation at the end of our discussion. We will try and reserve about 10 minutes to incorporate those points in. And if you'd like to ask your question directly, we'll be reaching out via chat to see if you'd like to be unmuted to ask and speak to the panel. With that said, I think everyone's pretty familiar, but it's my pleasure to introduce SERC Chief Technology Officer and DE Champion, Tom McDermott, as our Celebrating Systems Engineering Digitalization series moderator. And congratulations again, Tom, to you, Caitlin Henderson, Eileen Van Aken, and Alejandro Salado on earning Editor's Choice for your paper in the latest issue of Incosi Systems Engineering magazine. We'll drop the link to that paper in the chat.
Thanks, Mimi. So welcome to SERC Talks for 2023. If you're familiar with SERC Talks and you've joined us before, you know that we do these about every 2 months. And our goal is to bring in interesting sets of speakers that are outside of the System Engineering Research Center to our community. When we do our annual research review this upcoming November, we will have completed our 15th year of operation as a Systems Engineering Research Center and be moving forward into our next 5 years of operation. And one of the things we decided to do all this year is put together a series celebrating the digitalization of system engineering. So that celebration is a work in progress. Obviously, we're not there yet, and we'll be moving forward as we continue on in our next 5 years. But as one of the leaders in this country working with the Defense Department, we thought it was a good time to step back and do a series of events that looked at where we are. So this first one is great because it's going to give us maybe a really good understanding of the current state of digital system engineering, looking at myths and facts. So with no further ado, we put together this panel and with great help from Geoff Kerr, who is a SERC researcher from Virginia Tech. And so I'll turn it over to Geoff Kerr to start up the talk.
Oh, and thank you, Tom. What a tremendous privilege it is to be here with you today. I've got 34 years in aerospace and defense industry in a variety of roles, from product development, systems engineering, program project management. But my last role before retiring from aerospace and defense was a corporate executive leading a very talented team of systems engineers and architects for digital transformation. And now I'm honored to be, as Tom said, working at Virginia Tech's National Security Institute. Well, as every one of you knows, over the past 5+ years, digital transformation has been at the forefront of the service's priorities, to enable cheaper, more reliable, more rapid fielding and capabilities to the U.S. warfighter and our allied nation states. So digital engineering is certainly at the core of that focus on digital transformation. Unfortunately, there's some misconceptions with respect to digital engineering implementation and some of the terminology surrounding it. So today we have the privilege of just a panel of experts with us to explore some of those myths and misconceptions and let them share their experience with you about digital engineering and model-based systems engineering. So I'd like to take a moment to introduce you to them and then let them tell you just a little bit about themselves as well. So first, I'd like to introduce Tamara Hambrick. Tamara is the Boeing Defense, Space, and Security's Business Unit Systems Engineering Director. So Tamara.
Can you hear me, Geoff?
I can hear you. Thanks.
Well, thank you so much. Really, my passion and advocacy is really centered around transforming how we use data into knowledge and bringing the interaction with all of our customers from engineering, manufacturing, program management into the next century of visualization of how we perform our job. And with the differing roles, over the past 18 years, from Northrop Grumman and working in many of our defense programs to now at Boeing, it's just been really at the forefront of how do we better define digital thread and the sets of digital threads so we can bring together more cultural transformation of looking at our data-centric mind, as well as on our programs, how we can be more visible with that and show traceability and how we can improve our performance of our products. So thank you so much for having me here and giving me some insight or what I'm seeing in the trends now and some myths and facts around digital engineering.
Perfect. Thank you. And it's a pleasure having you here. Next, I'd like to introduce you to David Harrison. David is a scientific test and analysis techniques and uncertainty quantifications lead at Lockheed Martin. Some of my background provided me with the privilege of working with David, and has tremendous scientific and mathematical background and very practical applications. So David, welcome.
Thanks, Geoff. Yes, the scientific test analysis techniques is maybe one of the smaller digital transformations, but in my experience, I can go in and make an impact today. But I still run into a lot of resistance to change, resistance to whether it's going to work or not, or people just say, "Hey, we've been doing this for a long time. How can it get better?" And so hopefully I have a lot of experience in that. My other background as a master black belt, I've spent most of my career trying to implement changes, whether that's cleaning up a cabinet in 6S, classic Lean Six Sigma items, or trying to convince a company that doesn't do as much, high rate production, that high rate production techniques can still affect and improve our lives. So I'm excited to be here and can't wait to get started.
Perfect. Thank you, David. Like I said, it's a pleasure having you here. Last but certainly not least, I want to introduce you to Phil Zimmerman. Phil just recently retired after 40 years of service with the Department of Defense. She's supported the Navy, the Army, and OSD directly. She's a subject matter expert on digital engineering, and now even in retirement supporting OSD and some of the work that the Defense Science Board is doing. So Phil, it is an honor to have you here. It's a pleasure working with you. Please share anything you'd like to have as an intro.
So it's really nice to be here. There is a tremendous amount of work, I think, still left to be done at the convincing people level. And so I think the talents that I have and the way that I choose to engage with the community is to try to help people see where that demand signal for the digital products from the, Tom, I really like this, the digitalization of systems engineering, where those products have value, because a lot of times people don't see it. And so I'm still here. I'm spending some time, working with the SERC, working with the Defense Science Board. I'm on some curriculum committees to just try and help people understand the practicality of what they have and the practical way in which it should be used. And so I was really enamored by the talks. I told Geoff I was going to tell him, I believe in everything you're going to put out there. Which is totally not true, but there's a practical nature to digital engineering that I don't think we get a chance to explore very often. And I think we all want to see it, but we have to get past the hype. And so, Geoff, I'm very happy to be here, and it's really happy to be amongst friends again. Thank you.
Excellent. Thank you and welcome. Okay, so let's get into it. And again, you guys are going to provide the intelligence. I'm just going to play MC and try to smile a lot. So the first myth or expression I'd like to have you guys address, if you'd be kind enough, is the statement, and I've heard this said in numerous forums through industry, leadership, and even from the government. model-based engineering and digital engineering are the same thing in synonymous terms. So Phil, since you spoke last, can I pick on you to respond with your thoughts on that particular belief?
Yeah, you can. And I hate this question. I just think that this question causes people to get caught up in the hype and away from the nature of what it is we're trying to do, right? I don't, so they're not the same thing, right? But I guess I'm going to approach it from the standpoint of what does it matter if you call it, right? I used to, when I would give talks a lot, used to use the phrase underwater lead balloons, right? What if this is underwater lead balloon engineering? Would it engender less hype? Perhaps, but would it make a difference to how they're used? So no, they're not the same thing to me. Model-based engineering and systems engineering, look up the definitions and that'll tell you. They're not the same, but what does it matter what you call it? I think we need to look towards how do we get the benefit out of how we use it. Over.
Thank you. David, you work with a lot of different programs there within Lockheed Martin, especially in the modeling and sim world. Do you hear that same convergence of terminology? And does it matter?
There's probably a lot of definitions for these two terms, but the interesting thing I've found is that at the we'll say 20,000 foot level, 50,000 foot level, where a lot of our process, like corporate processes, are written, there is no digital transformation. We're still doing the processes of system engineering, mechanical engineering, electrical engineering, which are outlined in the steps, but we're using new tools. And to me, in the end, are we making people's jobs easier, more fun, and of course, making more profit, or delivering systems faster and better to the customer? So it's just fascinating that when I do look at those documents, they don't necessarily change. It's literally how we're achieving those results. So in a lot of the situations I'm in, I still have to design a test, but I'm going to use better techniques than I used yesterday and better tools. So,
and maybe that's one of those areas where you start to, where the definition does matter, especially if you introduce the term model-based systems engineering. So systems engineering is fundamental. It is what we do. It's just the method by which we capture the knowledge and do the decomposition and do the linkage. But when you start bringing in the modeling and sim, and we're going to get to a test and verification question here in a moment.
Right.
But it feels like that's where the greater digital engineering ecosystem becomes very important. Tamara, I didn't mean to exclude you, ma'am. Did you have anything you wanted to add as well?
I know one of the key areas I want to add is, our processes are standard and how we execute them. And that's how you transform into digital, right? It's the processes that become more of the workflows. And model-based engineering is using tools and techniques and methods within a tool itself, right? Or sets of tools. But one of the key areas that are different between digital engineering and model-based engineering, one for model-based is really about using modeling techniques and methods within your own domain, function, discipline. But when you come into the digital engineering, now it's not just technical data, it's now how do you really automate and bring a digital sense to the process, to the data, the visualization. And that's really what's different from model-based to digital. It's really bringing all those corners, not only engineering, but how do you plan for model-based? How do you plan with your costs and schedule? So those are some key areas, I would say.
Perfect. And while your mic is hot, I'm going to stay with you if I could, because the next question with your diverse experience, I think, will be very valuable. So another, I'll say myth that I have heard is that every development program should engage in digital engineering. Is that a myth or is that truth? Oh, Tamara disappeared on me.
Sorry, my phone was calling me, and so I wanted to turn it off. But you were saying about a new program for digital engineering?
Oh, yes. Should every development program should engage in digital engineering? Truth or fiction?
a portion should be, yes. So I would say it all depends, you know, on where's the higher risk that you need to mitigate, that you believe there are techniques within digital to burn down that risk, right? Not every facet of a new development requires us to move towards that, but eventually we will as you move towards manufacturing and sustainment. So I would state we really do have to crawl first, like as a toddler, and get there as soon as we can. But I would say very much in scoping for those new development, for which portions do we want to take those digital, let's say, principles into.
Thank you, ma'am. Phil, legacy programs. Is there a place for it, for digital engineering and digital engineering techniques and legacy programs?
Sure, I think there is, but much like with other things in SE modernization, I think you need to take a look at what are the benefits that you're trying to achieve. Don't do digital engineering in a legacy program just because it's the trend or it's the hot new topic, right? What are you, as Tamara said, what are you trying to do? And are there digital techniques that can help you achieve that aim? I think you have to look at a purposeful outcome to the employment of it before you just jump on the bandwagon because it's what your best friend and 5 of your bosses are telling you to do. Over.
Thank you, David. Are there analytical tools to help in making that decision and driving towards a good application?
Well, any good MBA student is going to say, are you going to make a profit on it? So that's the number one discernment for the entire program. But at the same time, maybe it's you've hired a bunch of younger engineers, and if they go through that process, they're going to be more effective on the next program and increase your profit there. So there's always an investment question at the same time. And then I won't say that I came up with this quote, but does everyone really need a smartphone at this point? I mean, are there some people out there that really need a flip phone? It's dwindling.
People that have them.
There are people that have them. And, if your kid is going to lose their phone in a month, certainly do not buy them a fancy phone. But there are programs out there that don't need it, but one of our oldest programs at Lockheed is actually embracing more digital engineering because it's just at the right time for their program to make that change. So, and they have a contract for many, many more years, and it's going to be great for them to do that now and reap the benefits in the long term. Other ones are going away. They're almost done. It's certainly not going to help them as much.
Okay, well, your mic is hot. You kind of stepped right into the next myth or statement, and that is that the digital engineering and model-based systems engineering, they will automatically, dramatically reduce your development time and costs.
If you do scientific test analysis techniques, it will. I mean, I've cut a missile program in half in less than an hour, but that's a far cry from reprogramming and coding all of your systems engineering into Cameo or Rhapsody. So that's the big question on the length of time and the investment and the return on investment. But there are so many digital transformations going on, and definitely connecting things with the digital thread, making your tools talk to each other. Part of STAT is adding, that's new, is this multi-disciplinary optimization, and it's fascinating how many of our tools are jumping on that bandwagon for us. And truthfully, I don't have to do a lot of teaching. They already have these tools on their desktop. They just need to download the newest version and hit the new buttons, and it's there. So there's a wide range of digital transformations, and some of it can occur tomorrow, and some of it takes a longer time. But everybody that's going to be working 5 years from now is going to need to understand how these tools work together. Over.
Thank you, sir. Tamara, so I'm going to a little bit of a curveball. Sorry about that. I didn't prepare you for this, but it makes me think with your experience. How do you work with program management and leadership to best understand how to, you had made the statement, it depends, and it really is about the use case. How to choose where and how to realize that improvement in performance and cost?
That's a great question. One of the key areas I always look at is in any non-conformance reports or corrective actions provided by customers to, let's say, similar to product lines that were resulted in, let's say, a defect in electrical mechanical, and really bring that forward to the traceability into systems engineering and see if it was more in our interface definition, our functional definition, or simulation of performance that would really drive for the case to program management, why we need to build in more of a digital approach for this certain set of use case. So if I hit home with a certain area of a program manager that they've sensed in their legacy knowledge, that is how I get more of a trusted relationship and advocacy to want to pay for that risk mitigation. Those are usually the cases, and how I work it through is from their perspective, where they have seen issues and non-conformances or anything that would have failed in their previous knowledge. And so that has worked pretty well.
Thank you. I believe a lot of SERC research has indicated that cycle time reductions and early detection of defects really adds to the rationale for applying model-based systems engineering, digital engineering techniques. Phil, from a government perspective, life cycle cost, what are the programs? Having worked with several program offices, it's about that program was legacy kind of mentality. Does the government as a whole look at life cycle costs and the employment of digital engineering techniques in deciding how much they're willing to try and invest and push for application?
So I'm actually not sure I can answer that question, because I didn't see it in my time in the government, and I haven't seen it since. Maybe others who have current experience with programs might be able to answer that. But I do want to point out to people that there is no such thing as the government as a whole. So do parts of programs or parts of PEOs look at life cycle costs? Well, of course they do. Do they look at total costs? Well, of course they do. But those are often not in the same vein or not in the same sphere as the people who are pushing the use of digital techniques. And so they're unable to tie them together, right? They're, look, hey, I'm digital engineering. I know that if you model this and you carry that model into, and of course you update it as a system design changes, blah, 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 all that sort of happy stuff. But then you update it as you go to sustainment. And now I've got a way to test, look at, do predictive maintenance, et cetera, in the sustainment world. Would that drive down my total life cycle cost? Of course it will, but those people aren't talking to the engineers that are pushing the digital in the first place. And so I think there's this whole of problem, or this whole of sphere, that a digital systems engineering would allow us to look at. I mean, what I can tell you is that I was on a number of programs where sustainment costs, my sustainment people, the logistics and maintenance people, were not at the table when we were doing the design. How is that possible? Well, for a variety of reasons, not all of which are good, it's possible. But could we give them an artifact, a digital thing that would help them, maybe if they did want to remain in their own little corner, that would help them then be able to do some work ahead of time? I think that all that's possible, but it's a user-based experience, right? This is not unlike the early days of modeling and simulation where you used to get I've had many people come up to me and say, I used a model once and it gave me a really bad result, so I'll never use it again, right? Well, you hear that about digital engineering too, but it's just a tool, right? Mm-hmm. Nobody's proficient with a smartphone. Well, okay, maybe people my age aren't proficient with a smartphone the first time you pick it up. It's a use experience thing that you have to go with. Over.
Yeah, no, I appreciate that. The very grounded answer. So I'm looking at the clock. I need to pick up pace here just a little bit. But David, this next myth is right down your sweet spot. So physical validation and operational tests can be eliminated with digital engineering techniques.
Sure, they can be eliminated with a lot of techniques. I mean, that was always the goal of Six Sigma, was to eliminate tests. I mean, if you know there's one chance or 4 chances in a million that you're going to have a problem or a non-conformance, then, you know, why waste your money on testing? And that comes from, of course, 30 or 40 years ago. So, I always joke within Lockheed that we don't validate our models for gravity, and you might go as far as to say we don't validate our models for the cantilever beam, but we also are trying every day to add to that list of models that we do trust, predictive models that are accurate enough to reduce testing. And as part of, I work a lot with aerospace and some conferences with their organization, and we're trying to reduce entire environmental tests from the traditional spacecraft development program, and that is, we've, you know, it's going to take 10 years and 40 years worth of data, but at some point, whether that's tomorrow or 10 years from now, the customer especially is going to say, why did we spend so much money on that physical test? It told us just what the model told us already. And again, is that tomorrow or is that 4 careers from now? I don't know. Depends on the model and depends on the situation.
Okay, this particular topic is very near and dear to my heart as we research the integration of development tests and some of the contractor-based tests with an ability to apply that for evaluating the operational evaluation for lethality, for survivability, all of those aspects that OT is focused on. To anybody that's willing to respond, is there a space for really driving down that OT by taking the information from the development test and applying it to OT analysis by use of these tooling?
I think a key part of that is taking every piece of data that we have. We try and do as many models as possible, not just one finite element analysis or CFD analysis,
sure,
multiple ones. And you're absolutely correct. A lot of our government customers are really pushing us to take data from development tests and apply that instead of having a solid wall in between development and operational tests. Let's take what we know and what we've shown and use that as a risk-focused informational discussion. And as a statistical engineer, that's really my job, is to say, here's the risk, here's what we know today, here's what the risks are, and then allow the team to make that decision. And if I do my job well, they usually end up all in the same boat. I mean, it's either a big risk or a small risk, and a big cost or a small cost. And if all those things are known and on the table, the decision is easier. So a lot of this goes into decision making as much as the engineering or the development of the actual product.
So Geoff, I want to jump in here, and this may be where you have to mute my microphone, I was once told there was a gentleman in the Air Force, wind tunnel testing, who once told me that an aircraft that was fielded approximately 40 years ago went through, I don't know, let's pick a number, 40,000 hours of wind tunnel testing, right? And fast forward 40 years and take a guess at how many hours they predicted for the wind tunnel testing for the F-35. 40,000 hours, right? Does anybody think that the F-35 40 years later is any less complex, or the missions are any less complex? No, of course we don't, right? So whether or not we can, it's clear that we have to find better techniques to get at some of this testing, right? Whether it's DT or OT, and you can argue for days about shifting left and all that sort of stuff, but it's clear we have to find a better way. And now we have one potential upgrade to our system engineering tool set. The digital or the model based or the digital portions to this. And maybe we ought to take a fair shot at looking at what it can give us to help us get at the problem space rather than maybe try to figure out how to use digital engineering to reduce tests. Maybe we look at the problem space and then try to figure out what tool is appropriate. Over.
Thank you, ma'am. I was about to ask you about, doesn't that violate Title 10? But I think you kind of touched around that. So Tamara, I didn't know, I want to give you an opportunity. Did you have anything you wanted to add to that?
I mean, from my experience, what I've noted more is how to bring T&E to upfront within systems engineering as really into those techniques and really bringing those test cases and verification activities to really more group them into our first article testing that is required. So bringing that community with us in the very forefront of those techniques, I think will help drive more of that culture to think the way that we think. I would say we in systems engineering about really bringing those techniques up front for having digital models of not only your original test plans that were paper-based or your verification plans that were paper-based, but how to then bring that into more of the modeling and sim environment for testing. And then how can that actually feed in to your burn down for, development tests and OT. I think that is really at the key of where I'm trying to infuse more of that type of cultural thinking with systems engineering. And that will then go forward and towards that life cycle thought.
Very good. Okay, since don't turn your mic off just yet. So the next one, I'm going to try to not start a religious war here in the chat or amongst the panelists here. But tooling seems to be at the heart of every engineer's implementation. So you have a rich experience with several businesses. So talk to us. All the tools, they work together straight out of the box, easy peasy?
No, they do not. No tool will work out of the box. We all configure, customize it to what we need that align to our approach, our method. There are many out there, whether it's electrical, mechanical, systems engineering, right? Some are embedded in the tools themselves. So what you're going to see is that some tools may not even have like really rigorous change and configuration management, workflow orchestration, role-based, access-based, security-based. What you start sensing is that some of these tool vendors will come with those additional services that aren't already inherent within the tools that we use, let's say in systems engineering. So we gravitate towards those, but we need to think bigger than that. But yes, that is very much true. None of that out of the box have everything and anything you need.
Thank you. Dave, I'm sure all of the MATLAB tools that are developed throughout Lockheed Martin all play well with the PLM environments, correct?
We can't even decide on which CAD tool to use across the corporation. So, that it's and as a digital transformation lead, I don't care what tool they use, but I do want it to be connected. I don't want them to have to hand deliver things between tools, although that takes a lot of work. There are advantages to a lot of the different tools, and I'm amazed at the tool companies. They are, and back to this, multidisciplinary optimization, the tools are are implementing these processes faster than our customers, the government, and our corporations can. You can buy an analysis tool that our engineers won't even know how to use for a few years. And our customers, every meeting I have with our test customers involve tool companies showing us their newest processes and advantages. So at some point, everybody has to catch up and stay ahead. And in a lot of ways, the tool companies are ahead of us using it and our customers putting it into policy. So that is a fantastic little three-way, as we stay in lockstep together, we can push each other at some levels. So no, they cannot all work together, but boy, a lot of tool companies are pushing that way. They know that if they can get to that point where they can give you an end-to-end solution, you're going to buy it and not have to do it yourself. But will they get there? That's it's fun to watch the race.
There's tools, and then there's translators, and you can become enslaved to either if you're not careful, I guess. So Phil, this kind of begs a question about standards and the rate at which they are updated, approved, and adopted, especially open standards. Thoughts on that?
Yeah, most of which are probably not repeatable in a public forum. So I think I have heard from more than one person, and from some very high level, very smart people, that all you need to do is adopt a standard, right? That's the same as saying all you need to do is pick a tool. The challenge with standards is one of time, right? And I've challenged just about every standards group I've ever talked to help me get to my standards faster, right? I can't wait 2 years. When I need a standard to do something, especially for things like tool interoperability, I need it today. I don't need it in 2 years, right? So that's the first problem. The second problem is that standards evolve, and please don't send me hate mail for this, but standards evolve based on the people who are in the room building the standards, right? And the federal government in particular doesn't pay enough attention to helping develop standards, right? And by the way, the federal government not being there isn't making the standards process faster. So just think about that one for a minute, right? But we need to engage in the standards. We need the standards faster. But I don't know that that's going to solve the problem either, right? We haven't been able to solve tool interoperability in 40 years, right? Since I've been working in modeling and simulation. And I've built 2 interoperability standards, by the way. What makes us think that we can do it today, right? So clearly, again, we have to change something. I would offer maybe a systems engineering approach to standards development might be an interesting way to look at. Ooh, Tamara, I guess you pursed your lips there. Think about that sorts of stuff that way.
That sounds like a great future SERC talk, right? So, maybe OSLC offers a future in that regard, just to put a plug in for that, but I'll let that lie for just a moment. So, Phil, clearly then the temporary solution, another myth or fact, is for an organization, be it along a programmatic line or across an organization line, you got to all use the same tool suite.
So I might surprise some people. I'm going to say, sure, it depends, right? If you have more money than God, you can get everybody to use the same tool suite. Sure, that works. It's certainly a solution, right? What do you need to achieve when? How fast do you need to achieve it, and how skilled is your workforce? Geoff, you made a really good point earlier that you can become a slave to a tool suite, but you can also become a slave to translators. I just want to remind everybody, the same thing I used to brief all the time when I was in the federal government, and nobody's shooting at us, right? When we're developing when we're using these tools, take a minute to make sure you have the right tool suite selected. When I was in the federal government, we advocated doing tool studies, right? We don't, I got to be careful because I'm no longer in the federal government. The federal government doesn't pick the first answer that comes to it usually, right? It takes the time to evaluate it. Why would we treat tool selection to develop these things any different? That's not an answer. It's not a solution, but clearly something has to change. Over.
I'll call you a mythbuster on that one. Tamara, your insight from the programs you've supported. Is it best to see the efficiency either organizationally or programmatically to all migrate to a common tool suite?
Well, okay. So I would think in the legacy side of the house, yes. Definitely. And when we try to transition to a new tool, when you're in a legacy program, what is that transition and up ramp for cost, skill, training, and understanding how to operate with that new tool, right? Stay with where you currently are until the enterprise has an understanding of its assets of data. So then I'm going to give you another thing. I would really hope that we would be creating more of common data models, data schemas that have mapping across our tool landscape, our systems of record, as having that integration backbone with orchestration. So you can have more of those APIs from each tool that implement their language their own way, their schema their own way, and just say, okay, do we all come to a commonality that we will plug and play into this, just like OMS, just like FACE and Victory, all the other standards we have for our platforms? Why don't we use the same rigor here within our environments for these tools? I think that's one of the key things that we need to get forward thinking in, is that we're never going to state that it's one tool. It's really about the data underlying it and how can we actually abstract it up and have it talk with each other. So you can bring that to fruition. I mean, that's really where I'm just thinking why we don't bring our engineering skills we've done on our platforms into our environment. I mean, that's my soapbox.
Well, no, and I'm actually glad you brought up data because, again, I'm trying to be mindful of time here, but you really kind of helped me walk right into the next topic, and that is authoritative sources of truth. ASOT. I mean, okay, so model base is all about the data. I get that. Yeah. So, when I hear in the myth behind this that I think I'd like you guys to address, and each of you to please speak to, and Tamara, if you're kind enough, I'll let you go first, is I hear authoritative source of truth, common data models, like it's this monolithic thing. It's this one repository. It's this vault of silicon that it's checked in, and it forever, like your drawing vault is preserved. What is your thought about that? Is there this just hard lockdown of a single source of truth? Over.
No, I'm going to say no. All right. So I spoke about this in past presentations and with our digital engineering information exchange working group. So the authoritative source of truths changes temporally over time. And that changes based upon what we place into it from the data that's built with its traceability and all of the additional metadata and provenance with it. And so it isn't just a PDM that exists that is vaulted for a release, right? It's a living, breathing thing that changes over time as you feed more interface definition and analysis, more modeling and sim performance data, more now the structural and stress and loads data. But what portions of that data, right, becomes your authoritative source of truth in time, right? It's not like you're vaulting all data, all test results, test runs, test procedures into a repository or so on and so forth. It's really a constructed, coordinated effort of what enables, let's say, virtual twins or the sets of digital threads that you're trying to bring together that eventually become, that temporal state of authoritativeness for you and your team, for the next downstream engineering manufacturing to take and build upon it. That's how I've always envisioned authoritative source of truth, not just a vaulted release of all data and files and everything else you could ever imagine in one repository. And I always get away from it's not single either. It's more of a federated sense of data that comes together and that brings authoritativeness to your teams.
Thank you. And I'm going to put words in your mouth because partly what I think I heard you say was it's about the configuration management or the authoritatively managed source of data than necessarily that vaulted. Did I get that right? Okay. David, what are your thoughts?
Well, as a former test engineer, my biggest fear was proof loading something to an old load or the wrong load or something like that. So I hope there's more authoritative truths out there. Like I'll go along with Tamara that it is not perfect. I'm not going to magically always have configuration control in a huge system. But if I don't have to go and scrape Excel and Word for the newest version and the newest thing, I always wrote my test procedures on the last possible days before the test, maybe even after the hardware arrived. So I had the focus of the CPEs, the people that own that hardware, and they also had the most latest numbers for me. We've also chosen some of our recent tools because they're able to scrape the latest designs out of our systems engineering and our CAD for our analytics, and then store those runs in a very organized server. So whether that achieves 100% configuration control is yet to be seen, but it heads towards that vision. And I've had too many years where I created a very fancy piece of fixturing for hardware, and then the hardware didn't fit because it got changed 4 times before it arrived.
Copy. All right, Phil, I'm going to let you have the last word, ma'am. So speak to me about your thoughts about this authoritative source of truth, and how does one know when you've found it?
Yeah, so I don't, first of all, I agree with everything that David and Tamara said and all the things that were flashing through the chat. I think I agree with everything that I saw. You know, it's more that it's not just one, blah, blah, blah. I think so how do you, nobody ever questions what does authoritative mean, right? And so I think David and Tamara will resonate with this one, is that authoritative is not found, it's declared. Right. Right now, we don't have a way to prove unless you can, unless you're looking at the real thing, right? It's authoritative, just a model, right? It's just a set of data. And I really believe right now that authority is declared because it's the right set of stuff to use for a purpose. Right. So you know, there were comments about, you know, it goes across all modalities, it goes across all of our competencies and all that. Well, sure it does, right? But is a large multiple faceted set of data the right thing to use? Is one the right thing to use? How big do I draw it, right? How much data do I need to describe the center of the earth, perhaps? Again, Geoff, if somebody knows how you can prove that it's authoritative, I'd really be interested in hearing that discussion, but I think it's more declared. That buys you a lot, though. If you're going to declare that something is authoritative to be used for a particular purpose, now everybody has the same starting point. Right. And I cannot tell you the number of senior analyst group that I was in where I was not the senior person. And they would argue over whose analysis is right, whose design is right. And they would skip the, did we even start from the same point, right? That type of argument that's just insane to me. So I think, you know, long answer to a really short question, I think authority is declared, not proven. Over.
Thanks. I think you just introduced a digital ERB where it's actually declared. Okay, so thank you. Checking the clock, it looks like we're inside the Q&A window. So I haven't been paying attention to the chat or the Q&A. Meanie, Tom, is there something that, Rich, out there that you would like to introduce at this point for the panel?
So I'm happy to read the Q&A.
Thank you.
Just in order. So the first question, George Hazelrig asked, how do you know the tools, methods, and processes are better? I think you answered a lot of that.
I don't recall where in the dialogue that would have been. Can we bring that individual off of you just maybe for some contextual clarification? Unless you know.
It was early in the talk, and I'll go back to the master black belt. My job is to measure business performance and business success with the finance teams, but with an asterisk. I mean, it's not always about making more profit. It could be improving your team's skills for the next program. It could be improving customer satisfaction, and they're willing to pay more for something later because it was of a higher quality. So, you know, all those MBA type aspects of a business are going to measure whether it's improvement or not. And I didn't get a chance to put this in here, but I relate a lot of my stories back to the last 20 years in the implementation of Agile. I mean, I think it's almost the 20th anniversary of Agile, maybe even the 21st. And, you know, there were a lot of times when it was required to be implemented. a lot of times when it wasn't implemented well, i.e. agile fall. And then, but these days you turn around 20 years later and everybody's doing it and doing it fairly well. And it is making more money and making delivering capabilities to the war fighter faster. So nobody would argue that we're going back to the old flip phone of waterfall 100%. So maybe that's, it's not a direct answer, but if you're going to write a paper for your MBA thesis, it's going to be around those items.
But I don't think you really know whether you're doing better or not, because you don't know what the norm is. You can't tell. So the only way to validate is with the mathematics. And I don't know where that's being done.
We do a lot of the finance mathematics. I think that would be part of it from our side. Again, the master black belt job is to say, did we make money? What is our return on investment? So, and sometimes I'll agree with you though, you won't know maybe for 20 years. Maybe that's the other half of this.
But the problem is you never know what the outcome of a decision that you didn't make would be.
Unless the
program, that's what you have to compare it to.
Yeah, unless the program does it both ways, which we've seen that happen.
And even then you invalidated the first thing because, then it's not a valid test.
So that does introduce another topic, and I can't remember which panelist spoke to this, but what I heard introduced into this thought of decisions in a program space and when you make them is introducing uncertainty quantification to help you guide and make that decision. Especially for the test and evaluation community, it feels like that is one of those places where at least, you may not know, but you at least have more data, mathematical data to shape your decisions. Did I get that right, David? You can pay me later.
So we do, Geoff, have quite a few questions to answer.
Please, go ahead.
So from David Griffiths, for Tamara et al., do you find it easier to overcome the non-user program project management resistance to MBSE from our time together 10 years ago? What's been done to grease the skids? This is from David Griffith.
Hey, Dave. Yeah, David, I worked with him at Northrop back in Baltimore. I think it's harder to overcome with program management, actually, just because they're still using, let's say, older applications methods in their learning and bringing them forward and actually understanding, even in contracts management, not just in finance and schedule, about how these models interplay and exchange information and data so you can realize a deliverable seed role, right? We're still not taking that perspective and teaching them along the way in our model-based journey. When we build these digital models to say, this is how we can plan better and bring in that cost, as well as contracts to understand how's that contractual requirement impact how we're planning. I think we need a better focus to help program management with all of those skills to move that forward. So it hasn't, in my experience recently, it's actually quite harder now.
So this is probably a related question from Dave Panson. Senior leaders, managers, finance teams, pretty much all non-engineers seem to be struggling with MBSE and SysML and SysML linkages to cost, schedule, and risk. Do you think lifecycle modeling language, LML, is gaining any traction? Is it helpful?
Yeah, so I think one of the key things you just stated, Dave, and I love this, is because for some reason, we still sense that we need to, based upon our defense customers' understanding, everything should be in an architecture model. And we should link in everything from cost and schedule and risk. And let's place that data, the resident data of that, within an architecture model. When you really just have to have that data model from architecture and cost and schedule and risk, and bring that up a level, right? And align it to an ontology, and then do that linkage. Now, I'm not quite sure about the lifecycle modeling language, if that would help with that, because I'm not familiar with LML, but I've heard of it, right? But SysML is so hardcore in the systems engineering. What would be that type of language we would move forward with right, across program management to engineering to bring that into fruition. So hopefully that gives you some insight of where my mindset is.
Okay. Don't know if this is Shauna or Sienna McNeil. Have there been investigations in confidence calculations as an additional way to build trust along with verification and validation?
Maybe that's all you.
Yeah, if we're talking about system testing, absolutely. I mean, the core of scientific test analysis techniques is measuring the test power and the test coverage. Test coverage is how many of the combinations did we test, and then the power is how confident we are, or how can we avoid false positives and false negatives. And most engineers do not have a lot of statistics background, but once they learn those concepts and get used to them, and same thing with the leadership, once hey, what is your test coverage and power? They start using it and making better decisions. So that's just my version of it, but there's a lot of levels in digital transformation that allows us to show that feedback in our confidence much better than we ever have before. So whether you apply that at the systems level, at the requirements level, or even in manufacturing, moving towards a Lean Six Sigma and indicating the Sigma value of your process, can really help people understand and communicate better than they were before. And they don't seem to go backwards once they grasp the concepts. And I'll put that in as a lot of the digital transformation. I've seen teams, especially in the past 10 years, we implemented a digital transformation in 2012. And we were trying to do a return on investment, and we couldn't actually put a number on it, but we asked everybody, would you ever go back to the old process? And everyone said, no, that would be horrible. So even if it cost more, the engineers, it made their lives easier, made their lives better. Helped us sleep at night. And that also applies to customers as well. So I think if you want to do a turnaround a few years later, that might be the ultimate question to ask. So
David, this was a similar question from Bob Netches. I'll paraphrase it. It's nice to see you in this, Bob. He talks about links back from testing to models. And so is that becoming a natural occurrence now, that the testing links back to inform your models, or is that something still sparsely used?
No, the techniques are not widely known. The tools are catching up to be able to do this almost automatically. That's a lot of our training, but we're actually our vision is actually completely the opposite. The only reason we run physical tests is to validate our models. So that gives people the chills, but I've tested a lot of physical tests, and I know all the variabilities. I wrote a lot of the accuracy specs for what we're doing at Lockheed, and I've seen how you can screw up a physical test as much as a model in the first place. So if anyone thinks physical is the gold standard, it has its own advantages and key parts and aspects in the engineering process. But models also, as far as test coverage and test power, have their own advantages as well. And the key is to have both, and to be able to put them together and do the analysis and show the figure to your customer or your management that says where the risk is and where we should invest next. Whether we do need an extra physical test, even if that's like a $5 million do something, great. I've seen management and especially government customers say that is absolutely worth that cost, given the information we have. Whereas before we would have said, no, we can't afford that, whatever, we're going to go forward. And we don't have the budget. And I've seen them go off and find the budget when they know it's a critical part of the mission success. Over.
I'm pausing if anybody else wants to jump in. Matt Blackman, is there an example where model-based engineering has successfully shown the efficiencies we all expect? It's a significant investment, so we need a quantitative value to get movement.
So
Go ahead.
I'll try that one. I actually can't bring anything forward, right? I no longer work for the federal government, but I guess I would push back and question the word significant investment. What are you trying to do that makes it so significant break in order for anybody to be able to bring a relevant example forward? I think we need to understand a little bit more about that. So maybe we can see it in the chat. Over.
I was going to respond similarly, I think, without, I'm certainly not at liberty to talk to programmatic details anymore. But yes, what you mean by that matters. But I think there are certainly causal type of relationships and analysis that validate there is a business return in several cases for the deployment of these techniques. And again, I have seen it in programs. So I'm sorry, I can't speak to specifics.
Just to pass out to all of you in the community, we are desperately looking for those case studies because there are very few published. So, and I understand that a lot of that's proprietary secret sauce, but another initiative that the SERC has been supporting is this digital engineering measurement framework. And so we do actually want people to be able to start publishing their experience that shows how they've quantified the value of this journey. All right, Mimi, we're at 1 o'clock.
Yep, we've definitely gone over, and I knew we weren't going to be able to get to everybody's question, but we appreciate all the input and discussion that's happened around this. Feel free to send along questions to serctalks@stevens.edu. There's also a link in the chat to the LinkedIn event for this to continue the conversation. We'd love to build this into the future talks happening in the series. Just 2 items to let folks know about. The ERIC DAU Quarterly Research Forum is taking place March 13th with the registration now open. And CSER registration is open as well. We're hoping to see you there to continue this discussion and more around systems engineering. But thank you all so much for attending today's talk. Thank you to the panelists for participating and making this, I think I can safely say, our most successful talk since of 26, from the series start of 2016. We really appreciate it. And that's it. Any last words before we close out?
No, thank you. Appreciate it. Love this. We should do this.
Thank you so much for the opportunity and for the panelists.
I think Geoff did a great job moderating this. So thanks, Geoff.
He did. He weaved us together like a digital thread of conversation.
Take care, all.
Thank you.
Thanks.
Have a great one.